So hi guys, welcome back. So today I am going to make you study about the chapter under biotechnology. So the first chapter is biomolecules. So getting into this chapter, so first we are going to understand the word name, the lesson name. So biomolecules. What is a biome? As you know, biome is a living matter, a living creature, whatever it may be, which is living in this nature, it comes under the biome. And what do we mean by molecules? Like atoms combine to make one atom, other atom combines to make a molecule. So we are going to study about the biomolecules which going to support the life. Okay. So as biomolecules, they are present in all the living matters, living organisms. So we are also living organisms, right? So that's why we also have biomolecules in our body. Our body contains of some biomolecules. So this is about the heading of the chapter. So under biomolecules, you have 5 types of biomolecules which we are going to study in this whole chapter. So what is the first one is carbohydrate. As you know, carbohydrate is a very important biomolecule or type of living thing, which is a type of protein which is very important for us. And carbohydrates, then proteins. These are very essential for a organism, like they are very essential for us to live. So the proteins and then lipids. Lipids are not but they are fatty acids, fats, and then enzymes. We're going to study about the different types of enzymes and then amino acids at last. So amino acids are very important. Okay, without amino acids, we can't have any functioning of the body. So about these 5 types of biomolecules, we are going to study in this chapter. So why are they important? Or what is their use? Means they are important for a living organism to live. Okay, so that's why they are known as biomolecules. They are very essential. If we don't have biomolecules, then we can't survive. Indirectly. So then now under these all 5, the first thing we are going to study is about the carbohydrates. So coming to the first biomolecule which we are going to study is carbohydrates. So first of all, what is a carbohydrate? Carbohydrate means which is composed of it is a molecule. Of course, it will be composed of the atoms. So, the first point you have to remember that it is composed of carbon. Second is hydrogen. And oxygen. And third one is oxygen. So, the combination of carbon, hydrogen and oxygen forms the carbohydrates C and H and O. So the carbohydrate, it is the most abundant organic molecule. Most abundant organic molecule. Organic molecule I am writing as ONG. Okay, it's the most abundant organic molecule. It is composed of the carbon, hydrogen, and oxygen. So in the word itself, you can see like carbohydrates. What do you mean carbohydrates means? It is hydrates of carbon. Okay, hydrates of carbon. So hydrates of carbon means carbohydrates. And then the very important thing which is very useful for the further learning is this empirical formula. Empirical formula. Its empirical formula is CH. H is taken 2. H2O, where the whole molecule again is taken n times. Okay, so it is very important. Remember, so this is a small definition introduction about the carbohydrates. Let us see. So carbohydrates means it's the first is most abundant organic molecule, and it is combination of the carbon, hydrogen, and oxygen, and it is known as hydrates of carbon, and its empirical formula is CH2O taken n times, where we have a condition here that the n should be greater than 3 or equal to 3. That's it. So this is very important. The n can't be 2. Like n can't be 2 or 1 or 0. So it should be greater than 3 or equal to 3. So based on this, we are going to write the different type of number of carbons we are going to write under this. So this is about the carbohydrates. Now the carbohydrates are defined. The main definition of the carbohydrates, it is defined as, just note that is very important. It is defined as polyhydroxyaldehyde, polyhydroxyaldehyde, or also known as ketone. So I am going to say why. So it is known as polyhydroxyaldehyde or ketone. So carbohydrates are defined as polyhydroxyaldehyde or ketone. So you can see that aldehyde and ketone, what are they? They are functional groups. So how it is aldehyde it is written? So aldehyde, the C double bond O, and we have H, and down another carbon will become. This is a aldehyde structure, and the ketone means the double bond will be on the second carbon. Okay, remember that. So here also you get C, and here also type of C only, and here you get, now that's it. So this is the structure of the ketone. So just remember the structure of the ketone and aldehyde, which is very important. And in this, what is a poly? More than 1 or 2. Okay, so more than 1 or 2, more than 1 or 2, which is known as poly. Poly means many, na? It is poly means known as many. And what is hydroxy? It is also a group. So hydroxy means OH. So you are having hydroxy, you can have more than 1 or 2, and which contains the functional group as this, is known as polyhydroxyaldehyde. Or sometimes it doesn't contain the aldehyde functional as group, but you can see the ketone. So this is known as definition of the carbohydrates. Now we are going. Carbohydrates are also known as saccharides. Also known as saccharides. So saccharides means what? They are sugars. They are known as sugars only. So we are going to call them as saccharides. Okay. So the carbohydrates are sweet in taste. Remember what the taste it is in? Sweet in taste. Okay. So this is about the definition and another name for the carbohydrates, and you can know like how this name has came. You can remember easily. Now we are going to study about the different parts. What are the 3 major types in the carbohydrates? Okay. So we have 3 types under the carbohydrates. Remember what are those 3 types is? The first one is monosaccharides. Why? Because I said now it is also known as saccharides. So that's why first one is monosaccharides. And the second one is oligosaccharides. Oligosaccharides. And the third one is polysaccharides. Okay. Polysaccharides. So these are the 3 types of saccharides, 3 types under the carbohydrates. Now, why are they grouped under 3? Means what is the reason for they have been divided? Means it is based on the number of carbons. Okay, based on number of carbons, they are divided into 3 types. Okay, we have to learn that why it is based like that. So based on number of carbon is divided into 3 types. So under monosaccharides, what is monosaccharides? Means mono is what? 1. So containing only 1 number of carbon is known as monosaccharides. So next oligo means you have 1 or 2, 1 to 2 monosaccharides, then it is known as oligosaccharides. Poly means more than 2, like more than 10 or till 10 or more than 10, it is known as polysaccharides. Containing is known as polysaccharides. Now under this also again we have further classification, wherein monosaccharides we have 2 types. In oligosaccharides we have 4 types. And polysaccharides again you are having 2 types. Okay, so under monosaccharides, what are those two types means? Wait, let me rub here. So under monosaccharides, what are those two types means? First is based on number of carbon, which is based on number of carbon. Based on number of carbon, one division, and based on functional group. Based on functional group, you have another classification. Based on number of carbon, you have like 3C, 4C, and 5C. What is C here? Carbon. So number of carbon, that's why 3 carbons, 4 carbons, 5 carbons. Where the 3 carbon is known as triose, where 4 carbon is known as tetrose, and 5 carbon is 5th carbon is known as pentose. Okay, so based on functional group, just now we saw like what are those two functional groups. The first one is aldehydes and the other one was ketones. Okay, so these are the monosaccharide. Two things, two subunits. Again, in those you are having the examples like this. Now, on oligosaccharides we have 4. That is, first one is disaccharides, disaccharides, trisaccharides. I am going to trisaccharides, tetrasaccharides. Tetra means 4, and pentasaccharides. Penta means 5. So these are the 4 things under oligosaccharides. And polysaccharides, you are having like hetero and wait, let me check once. So under polysaccharides, it is 2 types. That is homopolysaccharide, and another one is heteropolysaccharide. So these are the 3 types under the carbohydrates. That is monosaccharides, oligosaccharides, and polysaccharides. So under monosaccharides, again it is 2 types, number of carbon, 1 base, and another is functional group. Here 3C, 4C, 5C carbons. So 3 is known as triose, tetrose, and pentose. Under the functional group, that is aldehyde and ketone. And in the oligosaccharides, that is we have 4 types. That is disaccharides. Di means what? 2. Tri means 3. Trisaccharides, tetrasaccharides, and pentasaccharides. Under polysaccharides, we have 2 types. That is homopolysaccharide and heteropolysaccharide. So under this, the homo and oligosaccharides, these both are sugars, common normal sugars are mono and oligosaccharides, where they are sweet in taste, and they are soluble in water. They are soluble in water and they are sweet in taste. And the texture will be crystalline. So remember that monosaccharides and oligosaccharides both are sweet in taste and soluble in water and crystalline in structure. Okay, so this is about the different types. This is a small introduction about the carbohydrates and types. Now we are going to study separately about everything. Okay, so that is about the first is monosaccharides. We are going to complete it, and then about the oligosaccharides, and then polysaccharides. So coming to the first monosaccharides, we are going to study about these number of carbons and its functional group. So now we are going to study about the structure formation, like different structure and its names. Okay, first of all, what is the empirical formula here? CH2O taken n times, right? So now these only about the structure. By calculating the n in different forms, we are going to write its form under aldose and ketones, both types. Okay, so let me divide as first like this. Okay, because you are having 2 functional groups, you have to write on the 2 sides. So the first one I am going to write n is about aldose, under the structure of aldose, and here under the structure of ketones. Okay, both functional groups. So same formula we are going to write in different forms. So first, taking, as I said, n should be equal to 3 or greater than 3. So first we are going to start by the n is equal to 3. Where if n is equal to 3, I am going to write here like if the n is equal to 3. If n equals to 3, then what will be the structures and what will be their names? So if n is equal to 3, like what will get? C3, H2 3s are 6, H6 and O3, right? So same on this side also, C3, H6O3. Now how we are going to write the structure? The first one about the aldose, as aldose as functional group. So the C bond should be only to the first carbon. So carbon 1, 3 carbons should be this, right? Like first 3 carbons, C1, 2, 3. Here also 3 carbons, right? 3, 1, 2, 3. Under aldose, very important thing, the aldehyde group should be present only to the first carbon, C double bond O. Here in the ketones, ketones should be only present in the second carbon, C double bond O. Then the remaining right side should be with OH only. Hydroxy group, OH. Same here also, here OH right side and OH. And then the remaining part you have to cover with the hydrogen molecule. So here 1, 2, 3, 4. Why we are not writing this side? Because the carbon valence is what? 4. So 1, 2, 3 and 4. It is satisfied. Then here 1, 2, 3 only. So another thing you have to write here 4. Here 1, 2, here 3 and here 4. Same here this side. 1, 2, here 3, here 4. Here 1, 2, 3, 4. It is done. So nothing, no need of hydrogen. Here 1, 2 only. So again up you are writing up 1 hydrogen and sidewise 1 hydrogen. So what do you see? This is a structure under the form of aldose by the functional group of aldehyde. This is a functional group of aldehyde or not? Structure of aldehyde. This is ketone. So this is about if n is equal to 3. What we call as n is equal to 3? Triose. If n is 3, we call it as triose. Okay. So if in aldehys, we are going to have different names for them. So here the name is glyceraldehyde. Remember, just like this only. Okay. First one is glyceraldehyde. It is known as glyceraldehyde, and here it is known as dihydroxyacetone. Dihydroxyacetone. So we have different names based on the functional group. That's why it is differentiated to different names. This is known as glyceraldehyde. This is known as dihydroxyacetone. That's it about if n is equal to 3. Not more you have to learn. Just if n is equal to 3, as you know, it is known as triose. Now you have studied about structure, aldose, ketones, done. Okay, see, it is defined as polyhydroxyaldehyde. Right? We have remember that poly means what? More than 1 or 2. We are having 2 molecules here. And poly means more than 2. And hydroxy OH. And aldehyde means aldehyde group. Ketones means ketone group. Done? Okay. So now we are going to study under the if n is equal to 4. Okay. Now n is equal to 3 is done. Now we have to be greater than 3. So if n is equal to 4. Same. Again both as aldose and ketones. So what will be the structure of that? C is taken at 4 times. So C4 and H2 4s are 8. H8 and same O4. Same here also C4, H8 and O4. So first remember this process how you're going to write, because you're going to confuse here. First one is carbon, 4 carbons. Write 1, 2, 3, 4. Here also 4 carbons. 1, 2, 3, 4. Is it aldose, aldehyde? So first carbon 0 and make a use of writing same like that only, and hydrogen. It will be very fast. 1 hydrogen. Here second group. Okay, now writes are all OH, and down remaining part should be covered with H bond. H. Here we don't have anything. That's it. Here OH OH, OH, H, H. Oh, sorry, I have forgotten you to show that the formula satisfied or not. See, like if you are having 4 carbons here, 1, 2, 3, 4, done. If you are having 4 oxygens, 1, 2, 3, 4 oxygens done. And you are having 8 hydrogen. See, 1, 2, 3, 4, 5, 6, 7 and 8. So now it is satisfied with the structure? Yeah. See, and this side 1, 2, 3, 4 carbon, 1, 2, 3, 4 oxygens. Hydrogen should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So like this you have to study. See, aldehyde. So first group, first carbon is double bonded with O. Ketone means second one. The remaining right side should be OH. Remaining part with G should be with H. Now what is the name of if N is equals to 4? It means erythrose and erythrulose. Okay. Erythrose and erythrulose. So these are the names for this and that. Done. So what is 4 means? 4 means tetrose. Tetrose. Triose, tetrose, pentose. That only. So done with the N is equal to 4. Now we have to see like if N is equal to 5. So again same on the both sides. If N is equal to 5. So both structures same formula. So write just one side here. Okay. That is C5 and H. 2 5s are 10. H 10. And O same as 5. Carbon only 5. Now we are going to write in the both sides. So let us write small 1. So under same carbon, if N equals to 5, 5 carbons, 1, 2, 3, 4, 5. Write on the both sides. 1, 2, 3, 4, 5. So aldehyde again functional group first one. Other one is replaced by H. And other side is OH, 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 OH. And here H, H. Next, so this side also second carbon is double bonded with O, and this is OH, 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 OH. Down with H, hydrogen, and here you don't have, you're having up and down. Okay, got my point. So let us satisfy. So C5, 1, 2, 3, 4, 5. Oxygens are 5. 1, 2, 3, 4, 5. And about the hydrogens, they are 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Satisfied. So polyhydroxy, again polyhydroxy, aldehyde. And this is ketone. Same with this side only. The carbon double bonding should be replaced here in the first carbon. Here it should be in the second carbon. Done. So this is our N equals to 5. And the name is ribose and ribulose. The name is ribose. Here ribulose. Okay, so this is known as ribose, this is known as ribulose. That's it. And then the sixth carbon, which is very important. We are studying that from since we are 6th or 7th classes. What is that? Guess. N is equal to 6. C6H12O6. A very important molecule, that is glucose. So glucose is a very essential element, right? Even for humans or plants, etc. Glucose is a very important element. C6H12O6. Now we are going to see like how we are going to write its structure. Same 6 carbons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 carbons. Same here to the first carbon, second carbon. Remaining all are OH, 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 OH. The down is H. Here 1, 2, 3, 4. You can write it here or here. It's your wish. here OH, OH, or here yeah. Okay, so same again, let us satisfy 1 2 3 4 5 6 carbons, 1 2 3 4 5 6 oxygens, and H should be, hydrogen should be 12, 1 2 3 4 5 6 7 8 9 10 11 12. Same on the that side. So this is known as very important molecule, that is glucose, glucose, and this is fructose, fructose. So this is about the Na is equal to 6. Now I want you people to try if Na is equal to 7. It will come as glucoheptose and sedaheptulose. So same, you have to follow the same procedure, but 6 7 carbons, 7 oxygens, and H will be 2 7s are 14. Okay, you can try on yourselves. So this is about the structure, formation, and their names. I guess you have got these names, like if what if 3 carbon or 4 carbon, 5 carbon, 6 carbon, and their names under the aldose and ketose. So this is about the structure, formation, and the names of the structures. Now in the next video, we are going to study about the importance, biological importance of monosaccharides and oligosaccharides, and then we are going to continue with the ring structures. You have very important structure, that is ring structure, and before that we are going to study about the replacement of OH molecule. So we have wrote all OH molecule on the right side, but the OH molecule position also plays a very important role, major role. We're going to study about that and about stereoisomerisms. Okay, so till then, thank you guys.